Okay, in lesson 6.2, you're going to be learning about representations of functions. Okay, so the key idea here is that a function rule is an equation that describes the relationship between the inputs, which are the independent variable, and the outputs, or dependent variable. So the output depends on the input based on the rule. So you can see the function machine. If you input a -2 and crunch, 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 use the function rule 3 times x, or 3 times -2, the output, which is y, is -6. So we will be using this concept then to write some rules. So the first one, we see that the statement is the output is 1/4 of the input. So we know that the output is our y. This word is really important because in math it means equals. 1/4 can be written as a fraction. Of, in math, means times, right? So we use the dot multiplication, and we have the input, or x. So you would write y equals 1/4 of x. So in finding the value of y when x is 5, this is using substitution. We've been doing this a lot. So y would be equal to 4, and then substitute in the value that they're telling you, 5 minus 1. So y is equal to 20 minus 1, which means the output in this case would be 19. For number 3, the rule is to multiply by x. So 10 times the value of x, which they told us is 5. So y is equal to 50. That's the output. Y is equal to 7 minus 3x. Again, substitute it in and use order of operations. This is kind of why you did your fair game review. So you multiply before you subtract. So 7 minus 15 is the same as 7 plus a -15. A positive and negative means find the difference, and the answer will be -8. So writing an equation that describes each of these functions, okay, we talked already about this change in the input is +1, +1. Over here, you have +10, +10, +10. So we've seen this before. The change in y over the change in x would be equivalent to the slope. So the change in y is 10, the change in x is 1, so the slope of this equation would be 10. So our output y for number 1, I'm going to put it down here, y would be equal to 10x, and then we try it to see if we need to add or subtract or do something different, or, well, in this case, looking at the y-intercept, because remember, y is equal to mx plus b. When x is 0, the y value is the y-intercept, which is b, and if it's 0, also 10x plus 0 can be written as y is equal to 10x. Looking at 2, it's going up by 1. This is going up by 1. Okay, so that would be the change in y over the change in x. So in this case, the slope m would be equal to 1. Okay, I don't see the y-intercept. I'm not sure because we don't have a value of 0 for an input. So if I know that my equation is going to start off for number 2, y would be equal to 1x. Okay, so 1 times x. So 1 times 1 And then how do I get to 17? Right? Well, 1 plus 16 is 17, right? So if I add 16 to this value of x, because the coefficient 1 is what I'm multiplying, and then I try it out. If my x is 2, 2 plus 16 equals the output of 18. 3 plus 16 equals the output of 19, and so on, that I know I have a valid equation, the input plus 16. Okay, so here's my equation for 1. So looking at 3, I'm going up by 2. All right, and over here, 1 to 2 is plus 1, so these are plus 2, plus 1. So my slope in number 3 is equal to the change in y over the change in x. So it's 1 over 2. So I'm going to start by saying y is equal to 1 over 2x, so half of x. So let's see if that works, or if we need to find something to add or subtract, or find what that y-intercept is. So 2 times half, or 2 divided by 2 is 1. 4 times half is 2. 6 times half is 3. And 8 times half is 4. So it actually works for our table of values. Finally, 4. So we're going up by 20. Okay, each time. And here, again, up by 20. So if your slope is 20 over 20, isn't that equal to just simply 1? So for 4, we get y is equal to x, 1 times x, because we do the slope m times x. Again, we don't see a y-intercept of an x input of 0, so we don't know what the y-intercept is. But let's see what's happening here. So 20 till 10, if we're starting with x, we are going to subtract 10 to get there. Let's see if that works here. 40 minus 10, and it does. 60 minus 10, and 80 minus 10. So you just look for the pattern, and then you write it in the form of an equation. So here's a key idea. A key idea is that our functions can be represented by an input and output table and by a graph. The table and graph below represent this function, y is equal to x plus 2. Now remember this, we did this in lesson 4.1. We used this table of values, and the rule, so we used the table of values to come up with the output, but if we're given the table, right, we could find the rule. So as this increases by 1, the change in x is 1, this increases by 1, right? So the slope in this case would be 1, and that's represented right there. The coefficient of x is the slope. And then we look going this way, and 1 plus 2 is 3, so then you try that for each of these. If and only if you do not have an x input of 0. If you have an x input, or if you're looking at the graph, looking at the place where it crosses the y-axis would be b, right? Y is equal to mx plus b, and this positive 2 value becomes that second part of the equation, or you can just look for the pattern. So graph the function. Boy, this looks familiar. We did do this back in, again, lesson 4.1. So I will give you options. We have had so much experience graphing these functions. I will let you use the slope-intercept form, and I'll do that for number 5. The slope is equal to 1 over 1, because that's what 1 is equal to, the rise and the run. The y-intercept is equal to a positive 1. So you can graph, let me get a little thicker mark here. you could graph a positive 1 and then use the slope up 1 over 1 to get another line on the graph and then draw your line, okay? Or you could go back to 4.1 type of figuring it out and make an x, y table, okay? So 0 and 1. If x is 0, 0 times negative 3 is 0. If x is 1, negative 3 times 1 is negative 3. So in this case, we want to graph 2 points and then draw the line. So we would graph the origin, and we would go 1 and then all the way down to negative 3, and then we would draw a straight line. Again, using a straight edge or ruler would be the best. Finally, making a table, x, y, so 0 and 1. So 3 times 1 is 3 plus 2. I'm sorry. I was doing the first one. So if we do 0, we do 3 times 0 plus 2, so we would get an output of 2. Then the second one, 3 times 1, which is 3, plus 2 gives us an output of 5. So 0, 2 would be right here. And 1, 5 is right there. And then draw a straight line. See where the straight edge is very necessary, so be sure to use that. And finally, just a summary that you could represent functions in words saying an output is 2 more than an input. In an equation, y is equal to x plus 2. In an input-output table of values, in a mapping diagram, and in a graph. So there are multiple ways to represent the function.